Hey guys, so here's your guys' homework on more trig word problems worksheet. Okay, so make a drawing for each problem, set up a trig ratio, solve to the nearest tenth, and include the units. Okay, so for all these problems, highly suggest you always draw a triangle. Now, a sledding run is 300 yards long with a vertical drop of 27.6 yards. So it has a vertical drop of 27.6 yards, and the sledding run itself is 300 yards long. Find the angle of depression of the run. So, angle of depression is always formed with the ceiling, and the angle of depression is also congruent to your angle of elevation. So from the perspective of this angle, this is the opposite side, this is hypotenuse. So to find that angle, we're going to be using sine. Sine theta equals 27.6 all over 300. And to solve for theta, you got to do sine inverse to both sides. So theta equals sine inverse of 27.6 all over 300. So if we put that into our calculator, and just remember, when you guys put this stuff in the calculator, you have to make sure that you are in degrees. So you do have to go to the top right hand corner and make sure this bottom is set to degrees, right? Function sine inverse of 27.6, I believe, divided by 300, if I'm not mistaken. Yep, 27.6 divided by 300. So you guys round it to the nearest tenth. That's 5.3 degrees. 5.3 degrees is your theta. Okay. Number 2. A doctor is using a treadmill to assess the strength of a patient's heart. He sets the 48-inch long treadmill. So here's the treadmill, you guys. It's 48 inches long with an incline of 10 degrees. How high is the end of the treadmill raised? So it's right there. So in the perspective of this angle, this is opposite hypotenuse. So it's sine of 10 equals opposite over hypotenuse. Cross multiply, x equals 48 sine of 10, which is roughly, again, round it to the nearest tenth, 48 sine of 10, 8.3. It is 8.3 in terms of height. 8.3 inches. That's how high the end of the treadmill is raised. Okay? 8.3 inches. Number 3. So find the angular elevation of the sun. So we're trying to solve for the angular elevation, you guys, which is the angle that's formed with the ground of the sun when 12.5 meter tall telephone. So the telephone pole, you guys, is 12.5 meters tall. That casts an 18 meter shadow, which is on the ground. So here we have this, in the perspective of this angle, this is opposite and this is adjacent. So we're definitely going to be using tangent. Tan theta equals 12.5 all over 18. So to find theta, you guys got to do tan inverse of both sides. Theta equals tan inverse of 12.5 over 18. And if you guys put this in your calculator, tan inverse of 12.5 divided by 18. 34, rounded to the nearest tenth, 34.8 degrees. 34.8 degrees. Okay. Okay, so a person in a hot air balloon. So in this hot air balloon, you guys, there's already a person in here. There's a person there. At an angle of depression, so that's the angle that's formed with the ceiling, and they see a car that's 75 meters away. So from the person to the car, it's 75 meters away. How high is the balloon? So remember, the angle of depression is also the same as the angle of elevation. So this is definitely using sine. From the perspective of this angle, it's definitely using sine. So sine of 36 equals opposite over hypotenuse. Cross multiply, x equals 75 sine of 36. So when we estimate this, 75 sine of 36, that's 44.1. 44.1. That's how high the balloon is off the ground. In units, it is feet. 44.1. Okay, number 5. So these problems are more unique, you guys, because these are talking about your guys' eyesight. Okay, so a student wants to know how tall the flagpole is at their school. Her eye level is 5 feet above the ground. Okay, so she's already... So this triangle, you guys, is already in the perspective of someone's eyesight. That's already 5.5 feet above the ground. So she stands 36 feet from the base of the flagpole. So 36 feet away from the flagpole. If the angle of elevation is 25 degrees from her eyesight, how tall is the flagpole? So this whole length, you guys, is the flagpole. And we're trying to figure out how big is that height. Well, it would be nice to find this part of our triangle, you guys. I'm going to label that Y. And we already know that this is 5.5 feet tall. That part, right? So if we utilize that, we know that that length is 36. We can find this. And once we find this length, guys, by using our trig, then we can just add by 5.5 to get the whole length of our flagpole. So in the perspective of this angle, this is opposite and this is adjacent. So tan 25 equals opposite over adjacent. Cross multiply, y equals 36 tan 25, which is roughly 36 tan 25, 16.8. So that's roughly 16.8, you guys. But only this y value is 16.8, right? So to find the whole entire thing, the flagpole is going to be the 16.8 we just found, add by the 5.5, which is the distance from the ground to her eyes. So 16.8, you guys, plus 5.5. That means the flagpole is 22.3 feet. So again, that's tricky because the triangle is already elevated 5.5 because it's from the student's eyesight. It's from her eyesight. Okay. Number 6. Okay, so a person whose eyes are 5 feet above the ground. So this is from the perspective of someone's eyes, and they're already 5 feet above the ground. Is standing on the runway, so they're standing on this ground runway, you guys, that's 100 feet. away from the control tower. So here's the control tower, everybody. And we know the control tower... Okay, so from a control tower, that person observes... Okay, so the tower is 132 feet. What is the angle of elevation? So we know that the runway, you guys, is 100 feet. But we want to know what this angle. So it'd be so nice to know what this side length is, because then we could use our trig to find this theta, right? Well, if the tower is 132 feet, you guys, and we know the person's eyesight is 5 feet above the ground, then isn't the length of this, you guys, 132 minus the 5 for 127, right? Think about that. The tower's 132 feet. Her eye level's already 5 feet above the ground. So that means we do 132 minus 5, and it gives us this length right here. Because then we can utilize this triangle, opposite, adjacent, to figure out what our angle is. Tan theta equals opposite over adjacent. And to solve for this angle, we do tan inverse to both sides. Theta equals tan inverse of 127 all over 100. And if we put that into our calculator... Oh, what am I doing? Oops. Tan inverse of 127 divided by 100, which could create a degree of 51.8 degrees. 51.8 degrees. Okay, number 7. Okay, a golfer is standing at a tee looking up to a green on a hill. So the golfer, you guys, is down here. The golfer is down there. So the tee where we're at is 36 yards lower than the green. And the green, you guys, is where the hole is, by the way. Because he's looking up at the hill, right? The angle of elevation is 12 degrees, so find the distance from the tee to the hole. So you gotta find this distance, you guys, right there. From the tee to the hole. So, from the perspective of this angle, opposite over hypotenuse, so sine of 12 degrees equals opposite over hypotenuse. Cross multiply. We got x sine 12 equals 36, and divide both sides by sine 12. So x is equals to 36 sine 12, which is estimately, I delete all these, 36 divided by sine of 12, 173.2. 173.2 yards away, right? 173.2 yards away. Number 8, ladder leaning up against the building and makes a 78 degree with the ground, right? The foot of the ladder is 5 feet from the building. So the foot of the ladder and heels of the building is 5 feet away. How long is the ladder? How long is that ladder? So this is definitely using cosine. Adjacent hypotenuse, cosine of 78 equals adjacent over hypotenuse. X cosine 78 equals 5, and divide both sides by cosine 78. X equals 5 over cosine 78, which we need to plug into our calculator. 5 divided by cosine, oh, it didn't do the division sign for me. 5 divided by cosine 78. 24.0, if we're rounding to the nearest tenth. 24.0 feet is the length of the ladder. Okay. Okay, a person sitting on a 30-foot pier. So here's the pier, you guys. It's 30 feet in height. And there's a person sitting down on this pier. Person sitting down. Now the person's height level is 3 feet. So from this person, they're peering down and they see a bunch of whales here, right? They see a bunch of whales there. If the angle of depression from the person's eyesight is 20 degrees, which is also the same thing as the angle of elevation, how far is the whale from the eyes? So whales from the eyes, you guys, is this distance right here. So if we draw a nice triangle, another triangle in the perspective, or utilizing the fact that we're from the person's eyesight, this would be 33 feet, right? Because it's 30 plus the 3 from the eyesight. Okay, 30 feet, which is the pier, and then plus 3, which is the person's like bottom to their eyesight. This is 20 degrees, and we're trying to figure out the distance from the eyes to the whale. So this is definitely using sine, right? From the perspective of that angle, this is opposite hypotenuse. So sine of 20 equals opposite over hypotenuse. Cross multiply x sine of 20 equals 33 and divide both sides by sine 20. So x equals 33 divided by sine of 20, and this is roughly what? Round it to the nearest tenth. 33 divided by sine of 20, 96.5. 96.5 feet. That's the distance from the whale to the person's eyes. And lastly, after flying at an altitude of 500 meters, okay, so altitude, you guys, is the height of the helicopter. Height of the helicopter. A helicopter starts to descend when its ground distance from the landing pad is 11 kilometers. So 11 kilometers, you guys, is the same thing as 11,000 meters. And here is the pad. What is the angle of depression? So here, the angle of depression is the angle formed with the ceiling, right? So, which is the same thing as angle of elevation. So what's the angle of depression? Well, from the perspective of this angle, this is opposite adjacent. So it's tan theta equals opposite over adjacent. And to solve for that angle, you guys gotta do tan inverse to both sides. Theta equals tan inverse of 500 all over 11,000. Which in your calculator, tan inverse of 500 divided by 11,000. 2.6 degrees. It's 2.6 degrees. It's the angle of depression. So again, keep on practicing and do the best you guys can, okay? Good luck, everyone. Peace.